So what we're going to do today is build a better USB multimeter. I've mocked up some of the pieces that we're going to need already. And you may have seen this in a previous video. This is a USB multimeter that I put together previously. The problem with this is that it's not very accurate. It only has 2 decimal places for voltage and for amperage. But this was a lot easier to wire up than some of these type of things where it's a combination piece. So let me go ahead and take you through a little bit of how this got wired up. So I'm using external power to make the unit more accurate. And that's this 9-volt battery here. And that goes into a switch. The thin red and the thin black wire on this particular one are for the external power supply. Now, if you were powering this using the circuit, you wouldn't have any of that. Okay, so the yellow and black wire together, the black is common for both voltage and amperage. The yellow and black are for measuring amperage. This yellow and this black are for measuring amperage. The thick red and the thick black are for measuring voltage. Now, the ammeters have to be wired in series, and so the yellow and the black wire go to the same line to complete that circuit. The red and the black the voltage has to be measured in parallel, and so the red and the black are on 2 opposite sides of the circuit here. So that's how that's wired up. And then the confusing thing that many novices, including myself, have a hard time interpreting from the wiring diagram was this little jumper wire here. I added this yellow wire here to complete the circuit between the 2 USBs, because this has to be a complete circuit. So I wired in this jumper wire so that it would complete both sides of the circuit. So if you look at this, we've got on this, it's a little difficult to tell, but this is a black and a white. Black and a white. The white is positive, the black is negative. And it's not really black, it's kind of a gray. This is a cheap cable, so didn't use industry standard colors really. I had to figure that out with a multimeter. But regardless, these are the 2 leads that'll go out to the USB device. This is obviously input. You plug that into the power source. This is the output. Plug your USB cable into the unit. Now, some people might ask, and rightfully so, why would you want to build your own tester when you can go to your local hardware store, typically, and pick up one of these handy-dandy little units? We've got the input side here, output side here. It does a fine job of measuring amps and voltage. It does so passively without any additional power. And yeah, it does a fine job. The issue that I'm having is that I want to be able to run a bunch of tests long term. And I want to do it on camera. And I want to be able to measure batteries for how long they run, that type of thing. This just isn't quite up to that job. Plus, it's also using a little bit of power, so the ammeter is just a little bit off. It doesn't account for the power that this draws. And even if it does, if I'm testing battery longevity, for example, and this is drawing even 20 milliamps, well, that's 20 milliamps. You know, that's if the battery lasts for 4 hours, let's say, that's 20 milliamp hours that this device is drawing all by itself, and it'll throw off the test. So as neat as this is, and as convenient as this is, it just isn't quite what I need. The other thing is that this flips back and forth between volts and amps, and only has the single display. This has a double display, so it displays voltage and amperage at the same time. In fact, if I turn it on, now on the camera you're going to see this flicker, and there really isn't much I can do about that. It's just a difference in the refresh rate of the screen versus the refresh rate of the camera. Trust me when I say, yeah, in person it's just solid. It's the voltage is in red, the amperage is in blue, and it looks just fine. So we'll turn that off. But I'm going to go ahead and assemble this. And one thing to note, I've used two different barrel connectors. They're the same size in terms of size of pin. They're just one's shorter and one's longer. I was able to do this. I did it as a kind of a shortcut so I don't have to label the ports. I'll probably label them anyway once everything's said and done. But the short one is the input. The long one is the output. I did short and long heat shrink tubing to coincide with the input and the output. Hopefully everything I didn't wire it backwards or anything. I've done a couple of tests. It seemed to be okay, but let's go ahead and get this assembled. This just pops into place like that. Very easy. I'll put a little dab of hot glue just to keep it in place. I mean, it's not going anywhere, but it rattles around a little bit. You can hear that. One mistake I did make in putting this together outside the case is I soldered this switch in, and I really wasn't ready to solder the switch in. So this will take a little bit of creativity to get the switch mounted into here. All right, still powers up. Grab our leads. Short, short, long, the long. As soon as we plug this in, let's grab a little Raspberry Pi here. Actually, better yet, so let's grab our self-powered Mini. Plug that in. Switch it on. We got power. There we go. Power that up. And it seems to be working. There may be a little bit of calibration to dial in on here, but it's reading roughly the correct amperage draw, roughly. I shut this down once. It's definitely reading the right voltage, but I think the amperage, it might just be a little bit high. Nope, that's the correct amperage. This little light does draw 20 milliamps, so that is correct. And the voltage is reading roughly the correct voltage as well. This power supply will output about 5.1 volts, and that's pretty close. So our other multimeter might not have been dialed in properly. Yeah, the voltage is reading fairly accurate, but like I said, this other one, it was close, but I knew it wasn't accurate to begin with. Let's go ahead and open this up. I never did show a video on how to build one of these. because quite frankly, I wasn't impressed with it once I built it. This one here was a little easier to wire up because of the separate components. So the voltmeter, it's red and black, and the white is the power for the positive power for the voltmeter, and it's powered on the line. Now I could move this over to the battery. I'm just not going to. Not going to bother, because quite frankly, this is going to be rebuilt anyway. But the ammeter is powered off of the battery. That's why it's hooked up to the switch. There's the two blacks together. This is the power. These are the testers. Now, the black goes to negative and the white goes to negative. It essentially breaks the circuit and completes it through the ammeter, which is why it's wired as it is. And then you have the red jumper wire going from positive to positive again. It's very similar to how this one is wired up. Having the separate components made this a lot easier project to wire up. This isn't good enough for it wasn't accurate enough for the purposes that I needed it for. That's why we have this one.